Okay, so let's start with the mean, which is going to be the most important number we're going to look at this quarter. Now, for our class, there are two ways to symbolize the sample mean. The most common one you'll see from our textbook and from the notes is the symbol x bar. That's x with a bar over it. But APA notation uses the capital letter M, and that will also show up a bit. Now, the mean of a collection of values is the sum divided by the count. If you want a little fancier formula, you have x bar is equal to the sum, that's this Greek letter sigma x, that stands for the sum of the numbers, divided by the count of numbers. And for our class, n is always going to be the count. A little bit of algebra, you can get a couple other alternate versions that may be handy at times. The first one is that the count is the sum divided by the mean, or the sum is the count times the mean. Now, you can get all these by just multiplying and dividing the original equation. These all mean the same thing. Now, the reason why the mean feels like a typical value is because it is the point where the data balances. And what I mean by that is you find where the mean is and you put your finger right where the mean is, that's going to balance the graph. If this was a real life, three-dimensional graph, this is where you could put your finger and your graph would balance on it. Now, the way we compute the mean, again, is that we add up all the values. So, we have a 3 plus 4 plus 6 plus 6 plus 8 gives us 27. And then I divide by the 5 numbers that are there. And you see that the mean is 5.4. Alright, a couple examples. First, suppose we know the sum is 215 and the count is 32. So let's find the mean to the nearest hundredth. Well, we know the sum, we know the count, so the mean is going to be the sum divided by the count. It's going to be 215 divided by 215 divided by 32. So 6.72. Now instead, suppose we have the sum and the mean is, sum is 700, the mean is 28, and I want to find the count. Well, you can take an alternate version and say that the count is the sum divided by the mean. So if I go with 700 divided by 28, I can see there had to have been 25 values. And finally, suppose I had the mean and the count, but I want to find the sum. Well, that's the other alternate version, where the sum is the count times the mean. So if I go 30 times 14.3, I get 429. So the total of the values, if you add up all the 30 values, it should add up to 429.